So another thing I wanted to take a look at with you guys is talking about some of these word problems that you're going to see. Right here, we have a position, velocity, and acceleration functions. The textbook will typically show this as a function named s. I threw the of t in there just to make it a little bit easier for us. So the s is your position function, s prime is your velocity function, and s double prime, the second derivative, is your acceleration function. I will focus using these three notations mainly as I'm working through this problem. It is a little bit easier to keep track of the position, velocity, and acceleration functions separately that way. So first thing for you guys to see is here's an example where we have a ball being thrown upward from the top of a 160-foot cliff. Notice the 160 in our equation right here. With an initial velocity of the ball is 48 feet per second, and there's our 48 feet per second in our equation. And so we get this position function. S of t is equal to negative 16t squared, which we know represents, helps us with our acceleration, plus 48t, and then the 160, our velocity, and our starting position. Same equation as you guys saw earlier in the year, but now with substituting some more numbers into it. So the time t is measured in seconds, and our goal is to find the height, the velocity, and the acceleration of the ball when t is equal to 3. So first thing that I like to do here is find each of these functions. So first, I'm going to just rewrite s of t. So we have s of t is negative 16t squared plus 48t plus 160. Then from here, we'll take our first derivative. Our first derivative in this case is going to be our velocity function. So I'm going to write v of t is equal to, right, we apply our power rule. We have negative 32t plus 48. And then finally, what we want to do is we want to find our acceleration function. So we find the second derivative, name this a of t. So the acceleration as time moves on is equal to negative 32, which is a constant acceleration. Negative 32 feet per second is our acceleration due to gravity. So it's constant throughout, assuming that vacuum. Now, what the question's really asking us to do is find when t is equal to 3. So if we want to find our height when t is equal to 3, we use our height or our position function, and we just find s of 3. So we're going to substitute a 3 in here. We're going to say negative 16 times 3 squared plus 48 times 3 plus 160. And when you guys substitute in the 3, you should get 160. Right, this is 160 feet in this case. To our position function, right below here, we're going to also substitute in, let me just give a little separation here so you guys can see. We're also going to substitute in to our velocity function 3. So the velocity at when time is equal to 3 is equal to negative 32 times 3 plus 48, which in this case, the velocity when at 3 seconds is equal to negative 48 feet per second. Now, what that really means is we're moving down, right, 48 feet per second at that time. So at that point, we did start going up 48 feet per second, but now we are moving down. Gravity took hold, and the object, the ball, is now moving down 48 feet per second. Now, acceleration is where we'll have less work to do. Right? You guys substitute in a 3, but there is no t for us to substitute in for. So our acceleration is negative 32 feet per second squared, right? Or per second. Now, what that means, those of you in physics know, this is our acceleration due to gravity. Online, a couple more questions for you guys to take a look at. Let me know if you're having any trouble, and talk to you guys soon.